Hello everyone, in this video we're going to cover section 4.4, counting. Technically we have done this already, but in this section we're going to do this in a more concrete and official way. The first thing we'll be covering is the fundamental counting principle. What the fundamental counting principle says is that you have two events, A and B, and A can happen in n different ways, and B can happen in n different ways, then both events can happen as a multiplication of both of them. So for example, we did this before in section 4.1. Remember when a family have 3 kids? Well, there is 2 choices for the first kid, 2 choices for the second one, and 2 for the third one, so this will give you 8. And you remember from that problem, there were 8 different outcomes. In the homework, you have a question like this where you roll 2 dice. Well, there are 6 choices for the first one, 6 for the second one. So in total it's 36 choices or outcomes. As you can see, this is not new. We have done this before. Let's try a couple more examples. How many social security numbers are possible? Now, assuming you can have a 0 in the first place, then technically you have 10 choices for each of them. Why? Well, all you have to do is look to like a cell phone. You have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the number 10. So therefore you have 10 choices for each of them. Since you have 9 characters, this will be 10 to the 9, which is equals to 1 billion. So that means that there is 1 billion different social security numbers. Notice how this doesn't tell you what the choices are, but many times you don't care what all the choices are. You need to know that this is how many you have. Which, remember, these values we are getting is nothing more than the sample space. It's not the numbers in the sample space, but it tells you how many the sample space has or how many outcomes are in the sample space. Therefore, once you figure out this, let's say that you want to find the probability that this social security number 333112222, that this is the social security number of Batman. What will be the probability of that? Well, now it will be very easy. It's just 1 over 1 billion. That's it. Okay. What about student IDs? Well, that depends on what we mean by student ID. The question has to be very clear what they mean. Let's say case 1, that you can only use digits, which means numbers. Then this will be 10, 10, 10, and so forth, which is 10 to the 5th, and this is equals to 100,000. Why the number 10? Because of this. So therefore there is 10,000 different ID numbers if you only use digits, which may not be enough. Well, what about you can use characters? Well, characters means you can use digits, but you can also use capital letters. In that case, you have 36 choices. Why? Because you have 10 for this and 26 for this. So total is 36. So you'll have 36 every time. So it will be 36 to the 5th power, which is equals to 60 million. A little bit more than 60 million. And that's it. By the way, also notice here how we can repeat the same number. If you can repeat the same number, this is usually called with replacement. actually all the problems we just did is with replacement, which means you can use the same number again. This one is going to be without replacement, and you'll see why in 1 second. Let's say that there is a race, and assuming that there is no ties, okay, so nobody can tie. Well, then somebody has to do the first place, then you need the second place, third, fourth, and fifth. Now, since there is no ties, one person has to be the first place. That should be obvious, but the question is, how many can be the first place? Only one will be, but any of the 5 can be the first place. Then you have 4 for the second place, 3 for the third place, 2 and 1, which gives you a total of 120, which means there is 120 different ways to finish a race. If you have taken college algebra or another class similar to that, you should have seen this notation. This is usually written 5 factorial. If you haven't, it's not a big deal. So this is what the factorial means. If you have 6 factorial, that means 6 times 5 times 4 times 3 times 2 times 1, and then just multiply the numbers. So this is 720. Calculators, all calculators can actually do this. If you have 3 factorial, that means 3 times 2 times 1, which is 6. So you can see it's pretty easy. For all of this to work, it is required that 0 factorial to be 1. If this is not the case, none of this will work. The next topic is called permutations, and permutations uses this formula, and this is what it means. In how many ways can you choose K from P if the order matters? So for permutations, it means that the order matters, or the order is important. Well, what do we mean by order? Order means the selection order, or the way in which you are picking people or things matters. For example, let's say that you're gonna select 3 people from 10. Whoever you select first is gonna get $100. Second is gonna get 50, and third is gonna get only 10. So therefore, it matters who selected first. For example, let's say that you select Pedro first, so he gets 100. Then Rock, and then Batman. Now, let's say that instead, this would have been Rock, Batman, or Pedro. Notice they are the same people, but whoever got selected first, which in this case will be Pedro, he will get $100. If it was this case, then Rock will get $100. So that's what I mean by order matters. Then all you have to do is plug it into this formula, which the calculator can actually do this, but let's do this by hand at least once so you can see how it works. So let's say you have 10 people and you are selecting 3. So that we want to find is 10 permutation 3. So this will be 10 factorial, and then 10 minus 3 is 7, so it will be 7 factorial. If we expand these values the same way we did in the last page, this will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and this will be 7, 6, 5, 4, 3, 2, 1. Okay. All of this will cancel with all of this. So what you have left is 10, 9, and 8, and if you multiply, this give you 720, which means there is 720 different ways to choose 3 people from 10 when the order is important. Now, If you want to do that with a calculator, this is how you do it. First on the screen, type the number 10. Then go to Math, and then move the cursor to the right to get to PRV, which means probability. And then once you get to probability, gives you the choices 1, 2, 3. The second choice has NPR, so select that one. So now enter, and in the screen it will say 10 NPR. So this is how the screen will look. Choose the next number, which is 3, and the answer will be 720. That's it. Now notice that this only works for TI 83 or 84, but other calculators, actually all scientific calculators, can compute something like this. A slightly different method to do it, but all of them can do it. Now, if the selection order doesn't matter, then it's called a combination. So here, order is not important. So whoever gets selected first doesn't have any advantage over the next person. Notice how the two formulas are very, very similar. The only difference besides this one has a P and this one has a C. The main difference is that you have a K factorial outside. So notice that this part is identical to this one. So the extra part is this. Let's do the same example. Let's say you're choosing 3 from 10, but now the order is not important. This is usually spelled 10 choose 3. So then this will be 10 factorial divided by 3 factorial times 7 factorial. Remember that we did this part already. So from the last part, this was equals to 720. So therefore, this is the same thing as 720 divided by 3 factorial. Or remember that 3 factorial means 3 times 2 times 1, which is just 6. So this is 720 divided by 6, which is 120. So as you can see, when the order matters, the order doesn't matter, you have a lot less choices than when the order does matter. Remember that here everybody gets the same thing. So like the first place, there will be no first, second, and third place. But let's say the first place will get $20. Whoever gets selected second will also get $20. And whoever gets selected third will also get $20. So everybody gets the same thing. So therefore the probability that you will select Pedro, Rock, and Batman, it will be just 1 over 120. And that will be it. Now let's do an example or an application of this. These problems look pretty tricky, but they're actually straightforward. All you have to do is this a few times. So first, of course, read the problem. The question says, this semester, a Math 150 class has 4 Republicans, 6 Democrats, 3 Independents, and 4 Communists. So the first thing you need to figure out is how many you have total. Once you add all of them, you end up with 17 students. The question is asking to select a 4-member committee. For a committee, everybody has the same powers, which means the order doesn't matter. Which means we're going to use a combination, not a permutation. Okay? Now, remember that to find any probability, you need to figure out the sample space. Without the sample space, you will not be able to find the probability. So just keep that in mind, because we're going to need it in a little bit. The question is asking you what's the probability that you will select 1 Republican, 1 Democrat, and 2 Independents. remember you need to figure out the sample space. Well, what is the sample space? The sample space is going to be all the different ways in which you can select 4 people from 17. So this will be the sample space. No need to do trees anymore. So this will do the whole thing for you. On the top, it says you want to select 1 Republican. Well, how many Republicans you have? 4. How many you need? 1. So that's the Republicans. Then Democrats, you have 6, and you also need 1. Well, what about the Independents? You have 3, and you need 2. Notice that the question is not asking you for any communists, but they're still part of the group. So this will be 4, choose 0. I recommend you to write this part. If you don't write that, it's still technically correct, because anything choose 0 is equals to 1. But I highly recommend you to write that number there. The reason why I recommend you to do that is that by writing all of them out, it's easy to check that you're doing the right thing. This is what I mean. The number 17 is on the left, so all the numbers on the left have to add to 17. The number on the right is 4, and all the numbers on the right should add to 4. So that's how you can check you're doing this correctly. Now, if the asking is not asking to get a numerical solution, once you get to this point, you are done. However, you need a numerical solution, you have to compute each of them separately and then plug the answer in. So in this case, this is 4 for the Republicans, and then 6 for the Democrats, 3 for the Independents, 1 for the Communists, and then the bottom is 2380 using the calculator. And you divide everything, and you should check this. This is equals to 0.03025, which you rounded to 0.03. And that's it. You didn't get that one. We're gonna do 2 more examples, and hopefully it will make sense in the next page. All right, we're using still the same information. You still are selecting 4 people from 17. That hasn't changed for this question and for this one. But now the question is slightly different. It's asking you what's the probability of getting 3 Republicans and getting 1 communist. Now, the bottom is not going to change. It's still going to be 17, choose 4. Why? Because of this. You're still going to have this on the bottom. And on the top, it says you want 3 Republicans. Well, you have 4 Republicans and you want 3. Now, you have 4 communists and you want 1. You are done with the number 4, but remember you also have to include the other people. You have 9 people left, which are the Independent and the Democrat, but you don't need any of them, so you just write 0. Again, this part is not needed, but it's recommended to write it so you can check that that's the right answer. Sometimes, though, if you forget this part, the problem may be wrong, like you will see on this case. And remember, if you don't need a numerical computation, you can stop here. All right, so finally, the question is asking you, what's the probability that you have 2 Democrats? Again, don't forget that you're still selecting 4 people from 17. That's not going to change. The question says you want 2 Democrats. Well, you have 2 Democrats and you want 2. So that takes care of this part. But you still need to select 4 people. Therefore, you need to select from the remaining. How many you have remaining? You have 11. You don't care who. You just know that it's 11 remaining. And you're going to select 2. Again, 6 plus 11 is 17. And 2 plus 2 is 4. So that's why it's very important to have this part. In this particular case, if you forget this problem is wrong. Well, while here and in the previous problem it was okay. All right, people, that's it for section 4.4.